Hi guys, my name is Will and I've got today a Diptrace tutorial for you about patterns, components and how I manage these in my designs. So to start with, just a brief description of the types. Obviously, if you've got patterns which are the physical footprint of a component and show where the solder pads are and where their drill holes are, and if there's any silk screen that's defined. And then you've got your components, which are sort of the electrical description of an item, which show the pins of the component, the names of the pins, and show in a schematic how they're connected to other components. In Diptrace, these are kept in separate files. So this .lib file here is my pattern library, and this .eli file is the component library. And these two sort of interact, so every component has like a default pattern, and every time you drag that onto a schematic, it will have that default pattern. Of course, you can change that in the interface if you want to have a different footprint with a component. I use Dropbox to let me synchronize between computers and as a backup, and I find that's pretty handy. The only issue is that the way that Diptrace manages its libraries, it means that I have to sort of work around a little bit. It's a bit more of a hassle adding the library to Diptrace. But that's easy to work around, so I guess let's jump into it. If we open the Diptrace launcher, we can see that there's a component editor and a pattern editor, which, these are what make the libraries. We'll start with a pattern editor. Now, across here is, this is a brand new library, and across here you can see the patterns that are in this library. So normally you just start, if you wanted a new library, you just start editing, but what I'll do today is I'll open my existing library, and I'll just delete that from a previous attempt. And what we can do, if you have an existing library, you can do add new to library, and away you go. You've got a new pattern down here. It's called Untitled, but across here you can see this box, and this is really where all the magic happens. This is our wizard box, so you can change the name of the component, of the pattern over here. We'll call it axial th for through hole. You can set what reference designator it has. I'm going to say it starts with an R. This is your origins here, and this is where you sort of set out your components. Pretty similar to Schematic in that way, so a lot of this should be familiar. This drop down box here is pretty handy. What it does, if I click on a few, you can see it automatically generates a pattern, of this type. So we can use it for, four-sided devices like quad flat pack devices, BGA devices, anything like that. Even some sort of headers with offset zigzag type pins. For us today, I think lines will do it. And it's pretty straightforward. All you do is you just edit the number of lines is 1. And the number of pads is 2. I should say that sort of by popular request, we're doing an axial through-hole component, so like a resistor standing up on its end, a through-hole resistor. The principles are the same if you're doing a BGA device or a 44-pin quad flat pack or anything like that. So it's not that much difference. But once we've set the number of pads and pins, it's pretty straightforward to set your spacings here. So if we zoom in. That's out. If you zoom in, you can see here there's a dimension of 2.54 millimeters between the center of these two pads. We can quite easily change that to 3 or 10 or whatever, and Diptrace just automatically propagates that. If we had jumping back for a minute, if we had a two-row device, like a dip package or something like that, we could quite easily set the spacing between those rows here, and as you can see, that number's propagated into the dimension straight away. Let's just undo that. But it's pretty straightforward. There's not much to it. And if we did just that, you'd probably have a part that you'd be pretty proud to put into your pattern or into your PCB. But there's obviously a lot more you can do with that. Each of these pads can have has the ability to be set up independently. So we can set the pad number, which allows us to number pads which aren't necessarily in a nice orderly array. You can have, I'm thinking for instance like DPAC or something like that. That kind of package, you can put different pin numbers against that quite easily. the other thing you can do, and probably more importantly, is you can set the properties of the pad. Now each pattern, so this pattern, axial TH will have its own default patterns, and you can click on this button to see those and to edit those. In this case, it's a through hole with an oval, this size, 2.5 by 2.5, and with a 1mm drill hole in the middle. You can quite easily set that to surface mount, click OK, and those are automatically updated for you. Let's just undo that. But say we wanted to turn the first pad, or this pad here, into a rectangular one, all you have to do is untick that, and this, the same dialog pops up, which allows you to modify as you would like that pad. So we can see we've changed that to a rectangular pad. We'll undo that for now. The other thing you might want to add is silk screen. So you can do your silk screen from these drawing tools up the top. All you have to do is make sure that this is on top silk, or bottom silk, I suppose, if that's how you're marking your components. But top silk is most common. Pick a drawing tool, and let's just say we'll draw a circle around that, and then we can resize at our leisure. So we'll just make that look a bit prettier. And then from there we can we probably should make that separation a bit bigger. Let's make that 4mm, just so it fits in a bit better. And you can draw lines and arcs and all that sort of stuff as well, just as you would on a schematic or on a PCB. Arcs, you just click 3 times and it bends it around for you. Undo that. I'm pretty happy with that, to be honest. I think that's probably good enough. So what I'm going to do now is jump into the component library. You can see I've saved this into my pattern library, and so that means anything that references this pattern library will be able to use this particular pattern. Okay, so what we want to do now then is go to the component editor, and when this loads up it actually looks pretty similar to the pattern editor. Again, you've got a component already made for you, but I'm going to open my own library and add new to library. And you've got your untitled component here. This one we'll name again as the axial through-hole resistor. And this should look very familiar. We've got here the drop-down box with the different component types. 2 sides just draws pins on 2 different sides with no sort of silk screen. This one, IC 2 sides, a 2-sided IC with the rectangle in the middle, or a 4-sided one for your quad flat pack, or even if you just want to put it as 4-sided. You can edit the width and height, so you could have it really wide and kind of short and squat if you want. Dimensions here are in inches, but that doesn't really matter too much because it's just as it appears on the schematic. So all we need to do, we've got our through-hole resistor. We just want 1 pin on the left and 1 pin on the right. Set the ref desk, and we're pretty close to done. The only thing you might want to do now, or is good practice to do, is to actually attach a default pattern to this device. So if you click the pattern button here, you can see here's our component as it sits so far. We've got 2 pins. This is where your pattern will appear. We don't have any at the moment. Down here are all the libraries that I've added. You can add new ones from here. As you can see, I've got quite a few in there, but just click Add. Navigate to where your library is, which may just be in the Diptrace lib folder, or as it is here, it's in my Dropbox folder. Double click that, and if you click on your library there, then all the patterns in that library show up. The one we want is the axial TH. The good thing about Diptrace is it knows that this is pin 1 and it knows that this is pad 1, so it automatically connects those up. So it saves you sort of going through one by one. If it gets it wrong, you can always edit that here. So I could make that 2 and that 1. 1. But there's probably not much point doing that a lot of the time. So there we go. You click OK, and now you can see down here you've got a default pattern. What that means is that whenever you add this to a schematic, it'll automatically have that pattern attached to it. Of course, you can change it as usual by right-clicking on the component in the schematic and doing attach pattern. The only thing we might want to do here is just add a bit of a component to it so we know what it is. Worth saving, And that's really it. That you could get away with just doing that. There are some more advanced features, particularly with ICs. You might want to make use of this pin manager, which you can access from left clicking here, or you can actually right click on a pin and do pin manager. And this allows you to set all sorts of features to the pins. So you can name them. For instance, we can call that the anode and that the cathode, which I know doesn't make a whole lot of sense, but we can renumber the pins. So if they're all out of order, we can number them as we want. We can set length and position, and we can tick this box to show the name on the schematic. So there you can see the schematic has shown it as an anode. Let's turn that off for now. So that's pretty handy if you've got an IC and you want to name all the pins, from all the different types that can be on each pin. That's probably enough for now. What we'll do is we'll jump into a schematic, and what we've got here is when you've just made a new library, it's not going to show up in here. Mine does because I've done that earlier, but you won't be able to find it along here. So what you have to do then is go to library setup, and when you come into it, if you haven't touched this before, most likely that box will be ticked. And what that means is that you're using your standard Diptrace lib folder, and it grabs all the libraries in there and automatically adds those. If you don't want it to do that, if you haven't, if you've done what I've done and saved your lib files somewhere else, like a Dropbox folder, then you'll have to edit that. If you want, you can just drop it into your lib folder and it will automatically be added. But let's uncheck that, and I'll show you how to do it the hard way, I suppose. Basically, you come over to this side, you hit Add, browse to your library, and it'll be added. Mine was already in there, which is why I got that warning. And then you basically click this here, and it copies it across. Close, and you'll be able to see that library show up. And we can see this is the component library. So we see that this is our resistor component, and you can see over to the side here we've got the attached pattern. So if I save that just to my desktop, and then let's just make it a board, and we'll renew the design by refdes, find our schematic, and there we go. There's our 3 resistors, and they've got our silk screen, and they've got our pads just as we wanted, and the refdes set up. So that's worked pretty well. Save that as well. Now, the only thing you might want to do occasionally is, say you want to actually change the way that this looks on the schematic. Let's do that now. We can edit this. Let's just say we want to put both pins on one side. As usual, we can drag that. We can hit space to rotate it. If we go to Pin Manager, we can show the names as I showed you before. And let's just say we also want to renumber the pins. So if we look, down here, we can see that that's pin 1, the anode, and that's pin 2. Let's just say for some reason we want to change the numbering around. We want this to be pin 1. We can do pin manager and change it in here. But that can be, if you've got 48 pins or something, that can be a bit of a pain. You can also do pin properties and change it in here, but again, that's a complete pain. So if you've got a heap of things to change, Diptrace has a really neat feature, pin array names. And what this does, you can do it in a pattern as well for pads, but here you can select an order. So these are in a column. So if we start from, let's say we want to start from the bottom, make that the bottom one here pin number 1. So we put pin 1 there, and then we want to go up in steps of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to set the pin numbers. All we have to do then is click OK, and if you look now, that's pin 1 and that's pin 2. So if you've got 24 pins in a row, it's really easy just to number those 1 through 24, or even if you want to do them as odd numbers or every 5th number. And you can do the same for the pin names, or we can call that pin 1 OK or something like that. Whatever, I don't know in what circumstances you'd want to name them like that, but that gives you an idea of what it's possible to do. If we save that and go back to our schematic, we notice that nothing's changed. If we look at our library, that's the same. So there's just a little, tricky thing here, a trap for young players, as Dave would say. If you click off the library and back onto it, down here, you've noticed that the pattern is updated. But that's that one, but all our others are still the old component. If you right click on it, update from library, selected component, that updates just this component. If you right click update component type, it updates all those components to match the library. If we save that, as usual, we can then propagate onto the board. And that's given us, as you can see, that hasn't changed our pad layout or our pattern, but it's updated with the additional resistor. So you can do the same thing if you want to update the pattern. It's a little bit more tricky. There's one or two more steps, but let's just say we want to make this pad square for some reason. So we click properties. If we want to make it square when the other one's round, we can't use the default, so we have to untick this box here. Gives us these options. We could make it surface mount, but let's just stick with square for now, or rectangular for now. Change that to rectangular. Leave all the other dimensions the same. Click OK. That's been changed. Got to save that, otherwise it won't come through. And then we go back to the component editor. Okay, and we actually have to reassign the pattern. I found to, because you can see here it hasn't updated. So we go back to using this pattern button. Click again on our library to sort of refresh it. And you can see when I click that, this came back to the square or the rectangle. Click OK. Click save again. In our schematic, we have to update component type. Hit save, and then finally in our PCB we can renew design, and away we go. So there's a few more steps to that, but it's relatively painless. You probably could just skip the step for updating the component and just change the attached pattern in the schematic, but this way, if it's a component that's always going to have the same footprint, you may as well just update it in the library, so you don't have to do it every single time you drop that component into your schematic. That's pretty much it. I've cut it down from about half an hour the first time I did this, and then the audio broke. So I may have gone quickly over some things and slowly over others. But if you've got any other ideas or things that you think are a better way to approach it, or any questions, then feel free to comment or post over on the EEV blog forum. Other than that, thanks for watching.